In this lesson, we're going to talk about cross products and why they work when comparing fractions or testing if you have equivalent fractions. So let's jump right in. When you were younger, you probably learned that there was a pattern happening with equivalent fractions. And you started to notice maybe it was with a table, maybe it was with that magic little square box where it was like a magic number that you can use to turn one fraction to another fraction. So for example, here, you started to notice there was like a magic number of 2. And if you multiplied both your numerator and your denominator by 2, you can get the next equivalent fraction. You knew why they were equivalent. And we call this a multiplicative factor. Like there was something happening with that number 2, and you could even divide by 2 in the other direction. And you could use that to make an equivalent fraction. So if you had something like this, and you need to make an equivalent fraction, you would just look at your pattern and say, well, I know that 4 times 5 makes 20. So 3 times 5 is gonna give us 15. And that pattern worked out really well for us until we got a number that you could not easily multiply. So for example, if you had 3/4 is equal to 22, now this method didn't work so well. So we need to find another way to make this equivalent to each other. But before that, we're going to go to another method that you probably learned about, which was cross products. And it comes with lots of different names. And in some schools, I've heard shoot for the stars. Some schools go just do an X, like Wakanda Forever. We did that a lot in the Bronx because we were the BX. But you also learned that if you multiplied and an X, or you made cross products, that if that cross multiplication was the same number, you would also have an equivalent fraction. So 6 times 4 makes 24, and 3 times 8 makes 24. And because it was the same number, they were equivalent to each other. But why does it work, Math Marbles? Here's what's really happening. Although you don't see it, you are creating two like fractions. You're taking the two unlike fractions and you're giving them the same denominator. So this is the math shortcut that's really happening. You're taking 3/4 and you're seeing this. You're seeing 8 times 3 makes 24. What you're not really doing in the problem is multiplying the bottom part also by 8, that multiplication factor, to get a fraction of 24 over 32. And on 6 times 4, you're seeing 6/8, you're seeing 6 times 4 or 24, but you're not doing that other step of 8 times 4 gives you 32. When you do that, you can see that you do have two equivalent fractions. The trick part is when you're just doing the cross products, when you're only multiplying in this direction, you're only multiplying to figure out the numerators because it's always assumed that the denominators are going to be the same because you have like fractions. So that's really what's happening here, and that's why cross products work. And this is also super helpful because if you wanted to compare fractions, so for example, if I had 3/4, I'm going to use one that we know is not true. 3/5. We know that these two are not the same size. But when you multiply them, 4 times 3 makes 12. 3 times 5 makes 15. We see 15 is bigger than 12. So it's not, they're not proportional, but we know that 3/4 is the bigger fraction. But why? Let's uncover it. We see 3/4, we see that the 3 is being multiplied by a 5 to get 15. But again, the step we're not really doing is the denominators. 4 times 5 makes 20. So we're making fractions that have a denominator of 20. And the same thing is happening with 3/5. We're multiplying it by 4 to get 12. And when you multiply 5 times 4, the denominators, you also get 20. And so this is a true statement. 15 20s is greater than 12 over 20. And again, that is why cross products actually work for testing if two fractions are equivalent or for comparing them. What you're seeing is the numerators of a like fractions, but what you're not seeing is that you do have two like denominators. So it ends up looking like magic, but there's really logic and math to it. In a future lesson, we're going to talk about how we can use cross products to make equivalent fractions that are not as easy to make. But that's for another lesson. So I'll see you later, Math Marvels. Take care.